Welcome to this video. Here I introduce you our recent work published in Scientific Data. The paper title is Ocean Sciences with the Spilhaus Projection, a seamless ocean map for spatial data recognition. Our Earth's ocean covers 71% of the surface, which plays an essential role in geological processes. As we can see, the global ocean is an unbroken, interconnected body of water. However, in commonly used global map projections, they focus on the continents and artificially divide the oceans, which could limit our ability to capture numerous phenomena of the ocean and seafloor. For example, this Robinson projection splits the Atlantic Ocean, and oceans near two polar regions are largely distorted in their shapes and scales. So, it is desirable to have an ocean-focused global map that shows the continuous world oceans, beyond gathering and using data. Athelstan Spilhaus is an oceanographer who contributed to numbers of global map projections that emphasize the world oceans as a single unbroken water body bounded by continents. The square map, first published in 1979 and named as World Ocean Map in a Square, is one of the most acceptable maps. But it has been limited use in research, education, media, or policy decisions, because there have been gaps in both knowledge and practice in mathematics. Recently, this unique map is implemented by ArcGIS Pro. And here is a story about it. And we hope other open-source, widely used geoinformatics software, such as GMT and QGIS, can include this projection as well. In our paper, we present a set of geological and geophysical data, which are often used and visualized in continent-focused projections, but here, using the Spilhaus square projection. For example, this global topographic map. You can download all maps in this video by scanning this QR code. These are tele-earthquakes between 1990 and 2020. And the locations of mid-ocean ridge and oceanic trench. These are locations of hydrothermal vents and ocean drilling. Age of ocean crust and full spreading rate. Spreading direction and obliquity. Heat flow and marine sediment thickness. Marine gravity and magnetic anomalies. And these are sea surface temperature and CO2 flux. However, any projections for mapping the Earth must distort their shape or size to some extent, because they involve transferring information from a three-dimensional spherical surface onto two-dimensional maps. The Spilhaus projection has no exception. In this map of Tisot's indicatrix, each circle has the same radius of 200 kilometers. So, we can see, in the middle of the map, the Indian Ocean is slightly distorted, but in some oceans close to the edge of the map, shapes can be highly distorted, for example, the eastern and western of the Pacific Ocean. Therefore, it is important to be cautious when interpreting and comparing spatial characteristics in this projection. In the end, there is the animation of crustal reconstruction at ages from 250 to 0 million years. Again, be cautious about the aerial distortion, especially at the edge of the map. Thanks for your watching and welcome to visit my website.